We're going to look at what a table of values looks like on a graph. And we're going to put into practice the substitution practice that you have been working on. So turn to page 58 in your portfolio. This is page 58. Find page 58 in your portfolio. You can pause here if you need to get it out. And we are going to look at the equation y equals 3/5 x minus 4. This should look familiar. This should look like something we substituted in the last video lesson where we are replacing. So each one of these values right here is an x equals. That's what this is telling us up here. And this is an expression with x that we will be substituting in. I'm going to rewrite this so the fraction is a little easier to read. So 3/5 x minus 4 is the expression that we're going to plug into. That's what y is equal to. So this is basically a table where this is our y value and this is our x value, and we're going to substitute in each given x value to solve for what y is equal to. And this right here is the expression that is equivalent to y. And when we're finished, we're going to have an ordered pair that we can plot in our graph. So for this first example, you can see right here is where my x value is, and that's what I'm going to replace with the given values. So 3/5 times -10 minus 4. So you're going to want to use a calculator. You don't have to use a calculator. There are ways to do it without a calculator, but you're probably going to want to have a calculator. And there's a couple of things that you can think about. One is you can look at this just as if it's a fraction. And what I like to do if I have a fraction is make both numbers a fraction, because when I'm multiplying fractions, I can multiply across the top and across the bottom. I can also cancel anything from my numerator and my denominator. So I could be thinking of this as one fraction and have that 3 times -10 and 5 times 1. And if I think about it like that, 5 can cancel into 10 twice, and then that's going to be -2 because I had a negative there before. So 3 times -2 is -6, and that 5 canceled completely out, so it was just 1. So it's -6 over 1, or just -6. So I have -6 minus 4. And from there, I would like to think of a number line. So if I'm at -6, and I'm subtracting, which means I'm going to the left 4. So 1, 2, 3, 4 puts me right here at -10. I'm going to show you another way to do that if that was confusing. So when x is -10, my y value will also be -10. And so I'm going to write that in that spot over there. So we're going to take a look at this a little bit different if you're not comfortable with fractions. The way on the left here that I just did it, this is what I would do if I did not have a calculator or didn't feel like getting my calculator out. Let's talk about this fraction of 3/5. A fraction bar is the same thing as a divide symbol. So this 3/5 is the same as 3 divided by 5. And if I evaluate this on my calculator, 3 divided by 5 is 0.6. So instead of typing in a fraction, I can think of 3/5 as 6/10 or 0.6 right there. So I could substitute this in. So this would be 0.6 times negative 10 minus 4. And you could even do that at one step. So order of operations, my 3/5 I am writing as 6/10 times negative 10. So multiply by negative 10. On this calculator, I need to put my negative 10 in first. That's negative 6 minus 4. So I'm still at that same step there. Negative 6 minus 4 is negative 10. So another way of thinking about that problem. And what you can do is plot that. So this right here is negative 10. This value about right here is negative 10 on the y. So we have our x and y axes here. So left 10, down 10. This right here is approximately the point. That would be negative 10, negative 10. We're going to keep substituting these. So that's why we did the practice on substitution, because when you fill out a table of values, that's essentially what you're doing. You're substituting each time. So you would have 3/5 times negative 5 minus 4, or you can think of that as 6/10 times negative 5 minus 4. When I'm looking at 0.6 times negative 5, I would want to put that into my calculator. You don't have to, but it's not as familiar as when I'm canceling over here and I'm seeing that the 5s cancel out to make 1. So if I'm putting this in, 0.6 times negative 5 gives me negative 3 minus 4. And again, just for some number sense here, looking at our number line, if I'm at negative 3 and I'm decreasing, that would be going to the left 4. 1, 2, 3, 4. I would end here. That's a subtract 4 because I'm going towards the left. So this expression would be equivalent to negative 7. It is the same process if I'm thinking about this as a fraction. I just would put a little 1 here and show that my 5s cancel out with each other. So 3 times negative 1 is negative 3 minus 4 still equals negative 7. So my ordered pair, when x is negative 5, my y is negative 7. Looking at where that is on the graph, that's left 5, down 7, which is right there. Next, I'm going to plug in 0. 3/5 times 0 minus 4. Again, multiplication happens before subtraction. 0 times anything is 0. So I have 0 minus 4. Again, if we think of our number line, if I'm at 0 and I'm subtracting 4, going to the left, I would end up here at negative 4. You could also put that in your calculator as a check. My ordered pair would be 0, negative 4. So when I plug in 0, I get a negative 4. So that's going to be right there. Hopefully you're starting to see a pattern on your graph. So I pause right here and plug in the 5 and 10 and try those on your own. And you can see 3/5 times 5 minus 4. Think of that as canceling out. So then it becomes just 3 times 1, or 3 minus 4. On my number line, you can see if I'm at 3 and I'm subtracting 4, 1, 2, 3, 4, I'd be, oops, I'm not on my graph. If I'm at 3 and I'm subtracting 4, 1, 2, 3, 4 puts me at negative 1. Again, you can think of this as 0.6 times 5 minus 4 and get that product. Either way, you're going to end up with, when you plug 5 in for x, the result is -1, which is our y value, because we said this whole expression up at the top represents y. 3/5 times 10 minus 4. Again, you can make 10 like a fraction. 5 goes into 10 twice. 3 times 2 is 6 minus 4. And 6 minus 4 is 2. You can still plug this in using the decimal equivalent if you would prefer. Either way, when you plug in 10, the resulting y is 2. Oh, and I forgot to plot these. So we plotted 0, -4 right here. To plot 5, -1, you go to the right 5 and down 1. And to plot 10, 2, you go to the right 10 and up 2. So at this point, you're going to want a straight edge so we can see nice straight lines. If I line up my straight edge here, it doesn't need to be a ruler. Earlier today, I was doing some math in my car while I was waiting for my son, and I just folded a paper in half to get kind of a stronger edge to draw my line over. So we're going to connect these dots, and you should see that all of my points, if I graph them neatly, will lie in a line. So this equation represents a line. This table that I've just completed, if I plot those and connect my dots, you will see that they lie in a line. If you look ahead in your portfolio, you will find that there is another example like this on page 63. So page 63 for another example like this one.